So moving on from the parabola last video there, in the parabola we saw with an introduction to some of the new terminology here and where some of the original terms you'd have all been familiar with before, where they actually derived from. In this case here, we have a section plane cutting through a cone, and it cuts at an angle to the primary axis. It's inclined to the primary axis and it cuts through all generators in the cone. So we have an elliptical cut. We're going to do something similar to the last question on this. We're going to have a look here first of all at the graphic in the corner. We're going to add some labels and notes to that, and then we're going to come up here and start adding the objects in and projecting off at 90 degrees to see all of the terminology come together up here and see all parts, true shape of the ellipse, and all of the extras up here, and we label them as well. Just to read the question, the given cone is cut by a section plane resulting in an ellipse. Find the axis, vertex, focus, directrix, and draw the ellipse. We'll do that in just a minute. Add some labels here. Label the pictorial, we'll label in both places, and the orthographic using the following terms. The section plane. The section plane is the inclined plane that goes up and down here. I'll just label it along the top. The vertex, very hard to see. There are two vertices in an ellipse, but there's one bottom of the ellipse, top of the ellipse. I'll just write down V. The focal sphere. An ellipse has two focal points, as you'd have known from junior cycle, and there are two focal spheres as well. So this is a focal sphere down here. And this guy up top here is also a focal sphere. What's next? Focal point. Again, a little bit hard to determine, but where this bottom sphere, which is in contact with the cone, and it's also in contact with the section plane, where it touches the section plane around there is a focal point, and where this small top sphere touches the section plane roughly around there is also a focal point. Now you'd have learned to find focal points from taking the major radius from the top of the minor and swinging it. We're going to have different ways of doing it now, obviously using our focal spheres and points of contact to establish exact focal points. What else? Section plane, vertex, focal sphere, focal point, horizontal cutting planes, and they would be these planes here that go through circle of contact, extend on to intersect the section plane, and finally it will be directrix. So I'll just call them plane 1 and plane 2. Plane 1 and plane 2 there. And the final note is the directrix. Now there's two, so we have two directrices, but I'll just write down directrix here. And directrix here as well. Let's get drawing here. So they've already given us the shape on this worksheet. The shape of the cut section as it appears in plan is already given, so I don't need to draw generators or elements here and draw them in plan and so on. I don't need any of that. A lot of work already done for me, which is great. What I'd like to find first off is I'd like to find the focal sphere up top. So again, the focal sphere, it cannot be a little small one up here in the corner. That is only satisfying one part of the problem. It's only touching the cone. It has to be in contact with the cone and in contact with the section plane. That means it's going to lie along the axis, and it's going to be bisected out from this angle here because it has to touch both lines. If I've been accurate here, that's going to be the center point of the first focal sphere. Before I start drawing any circles here, I'm going to need some normals, so I will take the tangent angle for this circle. If I take it back to 2D terms, and go 90 degrees. Do the same on the other side of the cone. Take the angle of the edge of the cone and run off 90 degrees. And finally, take the angle of the section plane. Slide up. That should be 90 degrees to get me a focal point right there. I'm going to drop this focal sphere in with colour here so that it stands out. I put the two focal spheres in with a different colour actually. This is quite small now. There we are, that's the first focal sphere. That focal sphere touches the section plane at point F, the focal point. Along here is the section plane. And it is the section plane that is producing the cut. It's producing the shape of this ellipse. While I'm up here, I could also say that where the normals touch, where the points of contact are, gives me the full circle of contact around the object, and the circle of contact can be extended with horizontal planes to give me a directrix here. Time to move down to the lower half. As I said, an ellipse has a vertex and a focus, a second vertex and focus, so there should be another focal point here. I need to find the large focal sphere this time. I have the small one, this one up here in the corner. I need the large one now. Again, it has to touch around the whole perimeter of the cone. So it's going to be touching this edge of the cone, it's going to be touching this edge, but it's also going to come up and touch the section plane. Once again, it's going to lie on the center and it has to touch these two angles here, these two lines I should say. So I'll bisect my angle again. So I'm bisecting that angle right there. I get what should be the center point of the large focal sphere. Establishing my points of contact. Whatever you do, don't get confused between the bisector of the angle and the normal to the line, because there's obviously a huge difference. Each of these lines is a normal to the edge, and if you took it back to junior cyclographics, right back in first year, when you drew a circle and you wanted to put a tangent, you'd first need to find the point of contact. In this case, we have the tangent, we need the circle, and I'd like to get the points of contact exactly, so I know when I strike my compass around, I know exactly what I should be hitting. And I should be hitting all 3 points of contact tangentially. I'm here, I'm going to just label the normal line up, gives me the point of contact where it touches on the ellipse surface, which is the focal point. That's a vertex. That's a vertex. They're the two, basically the ends of the ellipse. The circle of contact that focal sphere makes with the cone is here. And extending that circle of contact using a plane, that will be, I call that plane 2. And this was plane 1. that gives me a directrix here. Not sure if they gave us that section plane at a 30 degree angle, I wonder. Yeah, 30 degrees makes it nice and easy. So we're going to take a view looking up perpendicular to the section plane. I'll just project off all the key points I have. So project the bottom directrix, the vertex, the focal point, second focal, vertex, and the directrix again. I'm going to draw in the axis of the object again, right up through the center, up through, and that axis along its journey there catches vertex, focus, focus, vertex. It's at 90 degrees to the directrix above and below. And I'll just put it in the center of the space that I have here, roughly. There's my axis. As a little side note, a directrix, the length of a directrix. Well, the length of a directrix depends on the size of the plane. A section plane can be as big or as small as you want, as long as it includes the full object. In this case here, it's made larger left and right. This plane up here, plane 1 or plane 2, can be as big or as small as you want, but usually for the sake of representing it in a diagram like this, it would probably be made the same width as the section plane. But the directrix, my point being, the section plane, if the section plane was larger, the directrix would be larger. The directrix has no fixed size. We just draw it in to whatever scale we think suits. So that's the first directrix and the second here. And I'm going to call that DD1. And I'll just call this DD1 as well. I'll just put a label of directrix down also. When you're learning the terminology at the start, you should be taking full note of them in all areas, because it's a good habit to get into. Directrix is at 90 degrees to the axis. Focal points falling on the axis. The vertices are on the axis, and that's the end of the curve here on the left and the end of the curve here on the right. Finally, we would need to take some projections along the curve that would allow us to get some extra points and freehand this in. There's no real right and wrong way to do this. You can take the projections wherever you want, really. The widths can be established from plan. So there's the vertex as it lies in plan. There's the other vertex as it lies in plan. I could take two widths along with the focal points, which is the latus rectum, up and down perpendicular to the axis. I'm going to mark in the axis in blue here in plan, just like it is up there in the auxiliary view. So if I just use the focal points while I have them, I might as well use them. There's one focal and there is the second. There are my focal points, and as I said, latus rectum is the label given to the double ordinate that goes through the focal point at 90 degrees. I'll call that F1 and F2. So I can establish two widths from each of those guys. Let's add in some more. I'll just take one below the focus, and I'll take one above the focus here. And these are completely random points now for me. I think two more along the way, one here, will work just fine. And I project all those up into the auxiliary view. And maybe if I was taking more care, I should have made them symmetrical about the center, but I'm just going to take the compass now, establish the width out from the axis, those points. This is the first one in from the vertex here, and I can mark my width up and down out to the first F2, widths up and down. The next one from F2 I have is here. On to the next one is the very same for me. Back to the focal point number 1. And the last point. On that auxiliary view now, I've plotted out a range of points, all taken from the section plane and widths established from plan. There's our ellipse. As I said, at junior cert, when you were introduced to the ellipse first, you'd have your center point. You'd be talking about major and minor auxiliary circles, major and minor axis. You'd be looking at focal points as a relationship of taking half of the major from the top of the minor and swinging. But now that is all a 2D method. Now we can see the 3-dimensional method of where focus, directrix, vertices and so on are all derived. Working over here, just to add the labels in. The labels here are vertex, major axis, minor axis, major auxiliary, minor auxiliary, focus, chord, ordinate and latus rectum. So I'm just going to start adding in as many as I can here. First off is the axis. Then there's the directrix line. There's 2 of those. I have the vertex. I'm going to just measure into the center. It's 72. If this was on an actual drawing, I would bisect that. They're looking for a major auxiliary circle and a minor auxiliary circle. The major auxiliary circle touches from vertex to vertex. The minor auxiliary circle goes along the short axis, touching along internally. So major I just shortened to aux circle, minor auxiliary circle. The major axis is here. It's the primary axis that goes from vertex to vertex, and the minor axis is perpendicular. So the axis is the line, and then the circle is obviously the circle that is the diameter of that line. The focal points have always been found by taking half the major and swinging it from the top or bottom of the minor, any point which lies on the ellipse. And a chord, an ordinate and latus rectum are the last 3. Chord is just any line that crosses through from one side of the object to the other. or from any 2 points in the object. Your focal chord would be the same green line but passing through the focal point. An ordinate stands at 90 degrees to the axis, going out and touching the curve. The double ordinate is this plus the mirror image. And finally, the latus rectum is the double ordinate that goes through the focal point. There's the ordinate, there's the latus rectum. That's all of the terminology associated with that section. So the section plane this time creating an ellipse and showing us where the two focal spheres come from, where the two planes along the circles of contact that those spheres are derived, thus giving us the directrix points, the two spheres giving us the two focal points, and all the terminology associated, all done. So using, just by maybe replaying if you need, drop in a note to explain each of the following. Drop in a note there to explain all of those as well in your sheet, please. That's all the terminology associated with establishing all the key parts of an ellipse.